This is the Analysis in Chains with Nathan Williams and Neil Kieran.
Welcome to Analysis in Chains. I'm Nathan Williams. Joining me today is Beniamin Mincu. Beniamin is the founder and CEO of Elrond, a layer 1 protocol that is focused on fixing the problems of scalability and efficiency. Beniamin, thank you very much for coming on the show today.
Very glad to be here. Thanks for having me.
You're joining us from Romania, are you not?
Yes, indeed. I'm joining from Transylvania.
Ooh, so you are the spookiest of protocols. So tell me a little bit about Elrond. What exactly is the problem with layer 1 protocols in your mind?
Sure. So I think we've seen Bitcoin come along and prove that you can do transfer value without a trusted third party. But then after some time, we've also discovered the limitation of Bitcoin. And then Ethereum came along and you had some improvements, namely that you could transfer 2 times as many transactions, but then you also had smart contracts added to that. But then we also discovered the limitations of Ethereum. So if Bitcoin can transfer about 7 transactions per second, and then Ethereum can process about 15 transactions per second, I think we discovered that this is not enough to have to really use blockchain in a very meaningful way. So Elrond basically started with a solution to this type of problem where we want scalability to be solved in order for blockchain to be able to be used in any meaningful real-world setting. So
the thing is, I've spoken to a number of founders who are doing layer 1 protocols. We had Zinshu Dong from Zilliqa on the show a while back. I've met basically a number of people, and they're all addressing this problem of scalability. The question I have is, what is Elrond doing that's different, and why do you feel your approach is the right one?
Yeah, I think this is a very good question. So there are a few approaches in the space, and there are especially 2 important things to differentiate. First is you have horizontal scaling and vertical scaling. And vertical scaling means that you basically try to process more transaction in the way Bitcoin process transactions, and you just increase the block size or do some other kind of optimizations. But then horizontal scaling means that you radically increase the throughput by bringing a process through which you can process transaction in parallel. So, and to put this in perspective, there are a few approaches to solving this, but the most important approach has been state sharding. And to give you some perspective on the difference with some project like Zilliqa, is basically Zilliqa tries to solve scalability by going and solving half of the problem, meaning that they do network and transaction sharding. So they bring some of the solution, and I think they can process about 2,500 transactions, but then they do not solve the hardest of the problem, which is state sharding. And state sharding basically for Zilliqa means that they can process transaction, but they cannot apply the same optimizations if the transactions are smart contracts transactions. So what we do at Elrond, we not only solve network and transaction sharding, but we also solve state sharding, meaning that you can can divide the network and process normal value transactions in parallel, but then you can also process the smart contracts transactions. What this translates in very simple terms is you can process starting with 10,000 transactions per second. And this is something which is very, very significant compared to what we currently see in Bitcoin, Ethereum, or even approaches like Zilliqa.
And this is not just for transactions. This is also for smart contract transactions.
Indeed. So on the one hand, you come with a solution to the throughput problem, but then on the other hand, we also solve the speed of the transactions, meaning that you can process these transactions and have them with finality in 5 seconds.
So I guess the first thing that comes to mind is, I mean, I've spoken to a lot of people working on layer 1 protocols. And what I'm finding is that the more people are working on solutions to these problems, the more complex the solution becomes. Are you finding that people are having a difficult time understanding the differences and the nuances of your solution? And how do you overcome that knowledge barrier that is needed?
Yes, so I think there's a bit of confusion generally, because what we are trying to build is an infrastructure solution. So it is especially designed for people with deep knowledge that want to use this kind of solution. And it's not necessarily targeted for the end users. We have a special wallet where we bring this solution and abstract away the complexity. But to answer your question specifically, I think there is a lot of improvement and a lot of work being done to clarify, simplify, and communicate this very clearly, because there is a lot of misunderstanding.
I suppose one of the things that has been in my mind for the past at least 6 months has been the coming of age of blockchain, of all of these different protocols, where we came from a scenario where everyone was trustless. Everyone was all about decentralization. We came from this history of crypto anarchy where everyone wanted to have trustless infrastructure. But what we're finding is that the more throughput we need, the more complex things become, the more we have to rely on people who are well educated and who are actually experts in this area of cryptocurrency. And we have just a different group that we're trusting instead of a trustless entity. Do you think that the future of blockchain technologies and layer 1 protocols is going to require more trusted entities, or do you think that the original trustless, decentralized vision of Bitcoin is still possible?
I think this is a very, very interesting question because decentralization is an ideal we tend towards, but in practice, I don't think that decentralization is an ideal we should aim for at the expense of anything else. So I do see that the point of decentralization was in Bitcoin to bring a different kind of system. And for Bitcoin, it was very, very different and very important to be secure and decentralized, but then the trade-off was in performance. As we moved forward, we have seen a lot of debate in how a project should be run, whether you had this example of Binance, of starting a project, bringing it at scale, executing at very, very efficient and fast speeds, and then trying to decentralize, or you had projects like Bitcoin or other projects which are more decentralized from the beginning, but have a necessary trade-off in execution speed. So what I think is a really good approach is actually to differentiate between the benefits you bring to the user or to the space you are trying to improve. If decentralization is just a word which you bring into the space, but then what you do is not useful at all, as we see with some projects that actually die just because they are decentralized, then I think it might be actually more useful to start, execute in a semi-centralized way, have a team that can prove that it can build the software or the architecture, and then try to gradually expand into a more decentralized ecosystem. So I think this is very interesting and an open discussion, and we have not seen a lot of meaningful and productive conversations around the topic.
And I guess what then would be the ideal target group that Elrond would be targeting? Are you going more for the group that cares about the decentralization, or are your ideal projects that would build on Elrond ones that would be more benefiting from this centralized first approach and then decentralizing later?
No, so I think we're targeting decentralized applications that want to build on Elrond, but the question which I think is very interesting and also useful for the conversation is how do we execute in such a way that we bring this solution as fast as possible to the market, and then once we launch in a way where we gradually move to a point where we have many people around the world participate in the network and have this as a real network which is distributed. And the interesting scenario for us is what we've seen is that most of the projects that are trying to build layer 1 are advancing really slow, including Ethereum, right? Ethereum has missed a lot of milestones in terms of time frames, just because they are very decentralized, and decentralizations comes at this expense of efficiency and speed. So what we want to do is make sure that we execute and bring a solution that works in the market. And then once you have really sexy technology that works, we have discovered that developers, researchers, and so forth are extremely curious to play with the technology, and you can much easier penetrate the market than by having a really bad product and then moving really slow, especially in such a competitive market as we have it today.
I want to ask you quickly about your consensus mechanism, because with every layer 1 protocol, really the innovation is around the consensus mechanism predominantly. Now, I understand you're using a variation of proof of stake. Maybe you could tell us a bit about it.
Yes, so I think there are two key components to our architecture. The first one is adaptive state sharding, where we have this sharding approach that allows for sublinear scalability. And the important point is that we add this adaptivity, meaning that the network can expand and contract based on the number of nodes that are present in the network. The second point is, as you mentioned, our consensus model that we propose, where we come with two important things. So we understood that proof of work is not sustainable, especially if you want to have global scalability or an architecture that could penetrate and could offer a solution that is globally available. So this is why we said, okay, just redesign things from scratch in order to have them very efficiently done. And as we looked at the research, the state-of-the-art research, there was this very interesting discussion around proof of stake and a few variations of proof of stake. One of the variations was delegated proof of stake, of course, but what we discovered was that delegated proof of stake essentially died once it reached a certain value point. So almost every network that has launched and is based on delegated proof of stake ends up in cartel wars that do not allow the network to expand. And
so
then
delegated proof of stake is the one where if I have coins, I can put them in a pool, and then the mining pool would stake them for me, and then the pool would end up getting the block rewards, because the computers that are part of the pool determine who creates the next block, something like
exactly.
that.
Exactly.
Right. And so it tends towards a couple of large players or a large pool dominating the staking.
Exactly, and this also means that once you have this large player dominating, you basically do not have any incentive of new people to join, to develop, and to contribute to the network. And we have seen several such architecture start in a very promising way, but then once they reached a certain threshold, the network or the expansion of the network would essentially die down. So what we thought was, okay, how do we solve this problem? Because we want to build on proof of stake. This is obviously the long-term solution, but we need to solve a few problems. One is we need to add an additional layer of security, because if the consensus algorithm is not secure, then you have basically something that is useless. So we thought we should basically combine proof of stake with a random sampling of the consensus group, which means that you do not know who will be in the consensus group. And then once the consensus group is elected, you have only 5 seconds to attack the consensus group should you want to do some kind of adversarial measures there. And then after the 5 seconds, the whole consensus group is basically randomly reshuffled. And this happens every 5 seconds and every 5 seconds and so forth. And this way you basically increase the level of security a lot and make sure that you cannot predict who will be in the consensus group. And once you can predict it, you basically randomize the process so that an adversary cannot do anything to the consensus group in order to influence the election. This was one of the processes we added. And then the second point was this PBFT mechanism, whereby you wanted to ensure finality. The consensus group is first very secure. The consensus mechanism is first very secure, and then second, you want it to be very fast, especially contrasting with what you have in Bitcoin, Ethereum, or even other projects. So in our case, you have finality after 5 seconds, which is very, very useful. So you eliminate the proof of work part, which is unsustainable. You have this very efficient mechanism, which is secure, and then which is also very, very fast.
So how do the incentives work with this? Because like if you have a proof of work, essentially your incentives are that if you do these math problems and figure out the mystery code to secure the next block, then you're rewarded with some Bitcoins. So you're rewarded for spending electricity to secure the network. With delegated proof of stake, you're rewarded for having a stake in the system. You're rewarded for essentially putting money on the line and saying, well, I'm going to help run the system. And so the rewards are given to the groups with the most money. Who gets the rewards with Elrond, with secure proof of stake? Is it more random from everybody, or is it random from those with the most coins, or how do you choose?
So I think this is a very good question, because this was also very important to us. For people to be able to run a validator, they need a stake, as with delegated proof of stake. But the difference is that in our system, you do not have these large pools. And this means that you basically, as someone new, you do not need a very large stake in order to process. transactions and help be part of the consensus, which actually means that you have a much more meritocratic system where you have a stake. It does matter up to a certain point if the stake is larger. So you have, but this is a bounded equation where after a certain threshold, it does not matter if your stake is larger. You also have a reputation, which basically records your behavior in the network, if your system is up to date, if you have processed things according to rules and so forth. And based on these two characteristics, you are part of the consensus group, you help contribute there, and then receive block rewards.
Yeah, fascinating. So I understand you guys are going to be launching your testnet pretty soon.
Yes, we are very, very excited about the work that has gone into this. So we basically released the first version of the very technical paper we proposed last year in May. We moved forward and released the first version of the prototype in July last year, made the prototype open source in November. And then from that point, we actually rewrote everything for the testnet. And we thought, we anticipated a 3 to 5x improvement in overall performance by rewriting everything, because we moved from Java to Go. And once we reached the first internal testing, it was revealed that we actually achieved a 30x improvement in performance compared to the prototype. So we are now at the point where we are very close to releasing the testnet and can't wait to share this with the community and start a kind of game similar to what Cosmos has done during the last few months, as a game of stakes, where you basically try to penetrate the network, do some kind of penetration testing as a game.
It sounds like everything is coming up Elrond. My last question is, we have been since the beginning of 2018 in a steady crypto winter. Has that negatively affected your ability to get a community started and people on board?
No, I think we have a very significant advantage in this respect, because we have been focusing on building the technology because we were self-funded. In contrast to many of the projects that have basically raised money and then lost almost all of it because of the correction that has happened in the market, and then had a lot of troubles because they basically ran out of money. We were self-funded. We did not take any kind of outside money, and this allowed us to focus very much on the technology and do not have a burned out community. Now, as the market recovers and prepares for the next wave, we see a lot of people that have been in the community since last year and are very, very curious and excited to hear more, especially given that we are very close to releasing the testnet. So the community is very excited and looking forward to something new, to bring them the hope they lost last year.
It sounds very exciting, Beniamin. How should people get involved if they want to find out more?
So we have implemented a kind of social mining, is called, mechanism during the last 3 weeks, where we have a website which is community.elrond.com, where anyone can register and can basically register based on their background. If they are a developer, they can register with GitHub. If they are just an influencer or a community contributor, they can register with social media profiles and so forth. And based on their background, they can contribute and earn some points within this community structure. And then these points can be transferred into Elrond. Once we moved more closer to the mainnet, these points will be transformed. So this is a very, very clear step they can take and just join the community and then contribute based on their background. And second, I think we have just announced the pre-sale and are going through a private pre-sale at this stage. So if people are interested, they can also contact us regarding that. But even more important, I think, if they're developers, we are preparing the testnet launch, and this will be very exciting for them to play with the technology.
It sounds very exciting. Thank you very much for coming on the show. Beniamin Mincu is the founder and CEO of Elrond, and you can find out more at elrond.com. Thanks so much.
Thank you. Thank you for having me, Nathan.